Hi, everyone, and welcome to Lesson 5, Area and Perimeter of Composite Shapes. Our objective for the day is to find the area of composite shapes and their scaled copy, so we're integrating that scale factor. We're going to discover the relationship between the perimeter of an original composite shape and the scaled copy. So yesterday we did area, and we saw that it ends up being the scale factor squared because it was units squared. Keep that in mind for perimeter. But before we start, a composite shape is just a geometric shape made out of multiple shapes or parts of geometric shapes. So like your blueprints that you created are going to be composite shapes because depending on the size of your rooms, it's different rooms put together. So let's go to our first example, which is also an exploration. So I want you to find the area of the composite shape. Now, I drew this myself, so I apologize for my lack of artistic ability. So I want you to find the given area and then find the area of a scale copy of a composite shape with a scale factor of 3 or half. So that's using what we did yesterday. So try that on your own first. So to find this area, there's many different ways. But for composite shapes, the goal is to break it into shapes that you can find the measurements of. So I'm going to break it here. So I'm going to see that the area of this bottom rectangle is 2 centimeters by 6 centimeters. So this is 12 centimeters squared. I then am going to notice that this rectangle is 8 centimeters by 3 centimeters, so 24 centimeters squared. Notice that I'm using, a strategy is using a color pencil to trace the whole side to make sure that you're looking at the correct measurement. Now, I don't have all the measurements, but I can find some. I know that this measurement is 3 as it matches the other side. I know that this measurement is 6 as it matches the other side. And I can actually find this last one as well because I know the full length of the side across it is 8. I know from here to here is 5. I know the dotted orange line is 2, making a total of 7. So that must be 1. Now I didn't need that for this composite shape, but sometimes you do. So the area of the composite shape is 36 centimeters squared. Using what we learned yesterday, since the scale factor is 3, to find the area, it ends up being 36 times 3 squared. And we get that the area of this composite shape is 324 centimeters squared versus 36 times a half squared, which gives us 9 centimeters squared is the area of that scale copy. Now we're going to keep using this picture, but now we're going to do the perimeter. So we just saw a second ago that we were able to figure out that this was 6, this was 3, and this is 1. Now, finding the perimeter is adding up the sides. So I'm going to give you a moment to do that on your own. Now, again, use the color pencil to make sure you don't miss a side. 3 plus 8 plus 3 plus 5 plus 6 twice. I can just say 6 times 2 if I want. Plus 2 plus 1 plus 2 plus 1. This all becomes a 14 plus 5 plus 12 plus 3. This becomes a 19 plus a 15. So this is a 34 centimeters. Notice it's not centimeters squared. Now, question 4, I ask you to find the measurement of each side of the scale copy using a scale factor of 3. Maybe create yourself a table, original, scaled, to make sure you get all of the sides. Go ahead. So here's my table for this. I put in my original side measurements, all of them, even if it repeated. I then found my scaled by just multiplying by 3 because it was a scale factor of 3. We're now asked to figure out what the perimeter is. And what we realize when we add up 24 plus 9 plus 15 plus 18 plus 6 plus another 18 plus another 3 plus another 9, we end up getting 102 centimeters. Notice it's perimeter, so it's not centimeters squared, which means we're not squaring the square factor. Let's test out a theory. Let's take our original, which was 34, multiplied by scale factor, which was 3, because it's perimeter, so we're not squaring. It's not square units. Let's see what this gives us. Gives us 102. So whereas area is units squared, so we have to multiply by the scale factor twice, perimeter only once. And that's our conclusion. So pause the video here for a moment, and this is similar formulas to what we had yesterday for area. Perimeter of scaled copy is the original multiplied by the scale factor, just once. Or you can go the opposite way and say that the perimeter of the original is the scaled copy divided by the scale factor. So we're undoing the multiplying of the scaled factor. Here is your next example. I want you to find the area of the composite shape. Notice that it is made up of a rectangle, and this right here is a semicircle, so it's half a circle. Again, for pi, use 3.14. And then once you find the area of the scale copy with a scale factor of 4. Go ahead. So for this, hopefully you saw that for the area, we need to break it into our two components. And so I organize it and I say, okay, first I'm going to find the rectangle. Okay, so that's 8 times 14, and therefore 8 times 14 is 112 centimeters squared. I then go to the semicircle. So that is the radius squared times pi, but it's semi, it's half, divided by 2. Well, I have to be a little creative, and I know that this line right here matches up with this. So that's 8, which means my diameter is 8, which means my radius is 4. So I can say 4 squared times pi over 2. Remember, we're using 3.14. And when I do this, I get that it's 25.12 centimeters squared. I add that to my rectangle in step 3. And I get 137.12 centimeters squared. This is the area of my composite shape. Now, using the fact that it's a scale copy that was created using a scale factor of 4, well, therefore, I must multiply by 4 squared, which is the same thing as 16. And I find that my scale copy has an area of 2,193.92 centimeters squared. Hopefully you think we're about to do perimeter. Now, before we do perimeter, I need to review circumference with you. Now, circumference is just the vocabulary word we use for the perimeter of a circle. So the circumference is equivalent to the diameter multiplied by pi, or since the diameter is just 2r, double the radius, we can do that as well. So I would like you to find the perimeter of the composite shape. Remember, trace to make sure you get all the sides. Go ahead. So as I said, tracing. So I'm going to start by doing the rectangle part, which notice the perimeter is just the outside. So it's the 14 plus the 8 plus the 14. So it's the 14 plus the 8 plus the 14. So 28 plus 8. So it's 36 centimeters. Then I want to do just this part, which is half of the circumference. So you can do this in two different ways. Again, the diameter is 8, so it ends up being 8 pi is the circumference, but we need to divide by 2 because we only have half. And when we do this, again, using 3.14, we get that 4 times 3.14, 12.56 centimeters. We go and put this together. We find that the full perimeter is 48.56 centimeters. Well, now I ask again, find the perimeter of a scale copy with a scale factor of 1/4. Remember, this is perimeter. So think about what you need to do to get there. So when we have our original, again, it's our original multiplied by scale factor, and it gives us our scaled copy. So 48.56 multiplied by 1/4, which is the same thing as dividing by 4, and we get 12.14 centimeters is the perimeter of our scaled copy. Okay. So here are your instructions. You have 2 practice problems with these instructions and then 2 with a different instruction. This one, for each composite shape, find the area and perimeter of the original copy, and then the area and perimeter of the scale copy based on the given scale. After you complete each question, in the play pause it, watch the video, make sure you make corrections to your work. Best of luck. Go ahead. Here's the answer to practice 1. Feel free and pause the video to look at the work before I then explain some of it, or watch and then pause. Notice that I did it in structure. I kept my notes organized. So I started with my area of the original. I broke it using the dotted line and making 2 rectangles. I realized that this line up here was the result of adding this to this to this. So I was able to label that as being 11 centimeters. And that way I could find the area of the larger and smaller rectangle. For the perimeter, I also saw that this 7 right here matched this 7 over here, and that this 2 matched that 2 to add up all of my sides to get 40 centimeters. Area, because it's the units squared, so I multiplied by 5 squared, versus perimeter is just units, so I multiplied by 5, and I was able to find the area and perimeter of my scale copy. So that's practice 1. If you have any questions, don't forget to come into Google Meet. Otherwise, go on to practice 2. Here's practice 2, same exact instructions. Go ahead. All right, so here is the answer to practice 2. Again, feel free to pause wherever you need. So I started by finding the area of the original, which I saw could be broken down into a trapezoid and a semicircle. Now, some of you might have decided to break it into a rectangle, which therefore that orange side is 6. This from here to here is 14, and therefore this from this is 6, and done a triangle. You would have still gotten the same area because you would have done the semicircle, which matches this right here, 14.13. You would have done plus the 6 times 14 for the rectangle, and you would have then added the 6 times 6 divided by 2, base times height divided by 2 for the triangle, and this would have still given you 116.13 millimeters squared. Then I found the perimeter, noticing that I only have 3 of those sides of the trapezoid and 1 of the sides of the circumference of circle. So that's why I said I got 18.84 as the circumference, but I want only half, so that's 9.42. I was able to find then the total perimeter as 51.92 millimeters. And then I used the pattern we observed for area of scale copies by multiplying by scale factor squared and perimeter by just the scale factor. That's practice 2. Now for practice 3 and 4, the instructions are changing. This time, you still have a drawing. But this drawing, notice I said this is the scaled copy, and then use the scale factor that was used to get back to the original. So we're going backwards now. So think about how that's going to work. So here's practice 3. Go ahead. So this is the area and perimeter of the scaled copy, because we're told that this diagram is the scaled copy. Now, I want to go back to the original. So I think to myself and I say, okay, originally what happened was to get to the scale copy, I took the original and I multiplied by the scale factor twice, and that's what got me to, oh, drew the arrow to the wrong place, 43 centimeters squared. So we multiplied by 1/5 twice, which is the same thing as dividing by 5 twice, which means we divided by 25. So we need to go in reverse and say the original area is the opposite of multiplying by 1/5 twice, which is dividing by 1/5 twice, which is multiplying by 25. And so our original was 1,075 centimeters squared. Versus the perimeter, since we used a scale factor of 1/5, so we divided by 5 once, I need to multiply once, and we get 200 centimeters was the original perimeter. So that's practice problem 3. One more to go. You guys got this. Here's practice 4. It is a triangle. It's actually a right triangle that has a semicircle connected to it. This is my scale copy. It was obtained by using a scale factor of 2. Go ahead. So here's last but not least, you have the area and perimeter of the scale copy completed. but I need to now find the area and perimeter of the original. Well, the scale copy was obtained by taking the original and multiplying by 2. So I need to do the opposite. I now need to invert and divide by 2. So for area though, because I multiplied by 2 squared for area, I need to divide by 2 squared, which is 4, and get that the original area was 22.13 meters squared, and the perimeter, 34.84, just divide by 2, and get that it was 17.42 meters originally. And there is composite shapes. We've reviewed area of different shapes, perimeters of different shapes, and integrated our scale factor. Next class, we're going to get three-dimensional. Bye, everyone.